In this session, we are going to learn how to solve the trigonometry equations. On the name, you can see that is f in equation and involving trigonometry function, right? All right, let's start with some example. And you might know what I'm talking about here. Let's take a look how to solve the trigonometry equation in the linear form. And the first example is psi x equal to square root 3 over 2. If you find the unit circle, then you can see there are two values x between 0 and 2 pi on the graph. You can see right here, this and this one, they both have the psi is equal to square root of 3 over 2, right? And however, if you remember that the graph of the psi functions is periodic functions going to infinity. So just like the way we have seen the screen, and the blue line is the sine function. This is the sine function. And the red line is where the y equal to square root of 3 over 2 is. And you can tell that, oops, sorry for the technical problem again. Let's see. It is sensitive. And this horizontal line, you can see all the intersection are solution. So which means this x corresponding this x and this x and this x and this x and this one and there are infinity many of those. They are all solutions. So how can we do that? So therefore you have x is equal to pi third and 2 pi third, and you will repeat it. Think about this as every period. So you will have x equal to pi third plus 2n pi, or x equal to 2 pi third plus 2n pi, where n is the integers. Okay, so there are infinitely many solutions for this. So that's your solution set. All right, let's see a brand new example without knowing anything. Let's see. We are going to solve this equation on the interval from 0 to pi. We are not looking at the infinity many solution in here. This is satisfy 3 cosecant x plus 4 cosecant x. Right? So to solve this equation, first of all, consider the cosecant x is 1 unknown. And I'm going to put all the unknowns together. So that will be 3 cosecant x minus cosecant x. Move the cosecant x to the left hand side equals 4. So from here we get 2 cosecant x equals 4. Therefore, cosecant x is equal to 2. If you recall, cosecant is the reciprocal of psi. If you don't remember the cosecant's special value, so that's another way. That means is 1 over psi x is equal to 2, which means psi x is equal to 1/2. So from here you can see psi x equal to 1/2 is this two value, and that is in the first quadrant and second quadrant. Second quadrant, first quadrant. If you remember that the special angle formula, psi of pi 6, that's 1/2. So it's pi 6. And the reference angle, this is pi 6, which means this next angle is divided pi minus pi 6. It's 5 pi 6 right here. Okay, so therefore your x is equal to pi 6 or 5 pi 6. To write your solution, we usually like to write as a solution set, put in this set notation. So your solution has two values, pi 6 or 5 pi 6. Okay. Let's see another equation. We are going to solve square root 2 cosine x plus 5 is equal to 4. So from here, I only have one unknown, which is cosine x right here. So let me move the constant to the other side, which subtract the 5 from both sides. Square root 2 cosine x is equal to -1. I divide both sides by square root 2, therefore cosine x is equal to -1 over square root 2, which is negative square root 2 over 2. Alright, so if you think about the cosine function is about the 4 quadrants. Cosine is related to x, right? So in the second quadrant, cosine is negative, and also third quadrant is negative. And I know that the special angle is pi 4. Cosine pi 4 is equal to square root 2. So which means the reference angle is pi 4. That means you have an angle. Let me use other colors here to distinguish that. So you have a reference angle right here is pi 4, which means this is the angle we're looking at. The is pi minus pi 4, which is 3 pi 4. And another one is, if you think about another angle on the third quadrant, the reference angle is pi 4 as well. So this angle measurement will be pi plus pi 4, which is 5 pi 4. So therefore, the solutions for this one is 3 pi 4 and 5 pi 4, but it did not say that the solution must be only from 0 to 2 pi. It's all the real number. And consider the period of cosine function is 2 pi. So therefore, your solution x can be 3 pi 4 plus 2n pi, where the n is integer, or x can be 5 pi 4 plus 2n pi, I could take 2n pi, and n is any integer. Okay, so to write it as a set notation with x such that x equal to 3 pi 4 plus 2n pi, and x equals to 5 pi 4 plus 2n pi, where n is any integer. So that is the linear equation, what it looks like. And the angle is very simple. It's a single angle. Let's see some example, which is when you take the cosine, inside the cosine, sine, or tangent, or when inside is multiple angles, what should we do? So it's a multiple compound angle. Let's take a little number 3, and I give you some suggestion for that. So showing 8 cotangent 2x minus 5 equals 3. Again, the unknown is in the cotangent, where I boxed it. You just consider that is one big unknown first. So you are going to isolate cotangent 2x. So first I'm going to add the 5 on both sides. So 8 cotangent 2x is equal to 8. Divide both sides by 8, so that will be 1. Cotangent 2x equal to 1. Right, so in this case, I would like you to not worry about the 2x here. Just think about cotangent. Cotangent of what angle is equals to 1. Right? So that's why I asked you to find the general solution from the unit circle. And I know that cotangent pi 4 is equal to 1, right? Just consider the from 0 to pi first, because cotangent period is pi. Alright, so from here, then I can get the idea that 2x must be equal to pi 4. But also, cotangent is periodic function and repeated every pi. So therefore, I can add the n pi with n is any integer. And then I can solve for the x, which means x is equal to half of pi 4 plus n pi, which means pi 8 plus n pi half. Okay, So that is your general solution. But this is question it asks you to find the solutions in the 0 from 2 pi, then you are just going to substitute n equal to some integer, and then to see if it is in the interval. For instance, I started from n equals 0, so x is equal to pi 8 plus 0 times pi divided by 2, that is pi 8. When n equals 1, x is equal to pi 8 plus 1 times pi divided by 2, which is pi 8 plus pi half, that will give us 5 pi 8. Okay, and then n equals to 2, x is equal to pi 8 plus 2 times pi over 2 plus pi 8 plus half pi plus another half pi, that will give 9 pi 8. Right. So from here, and you might notice that when you move to the next value, you just add another pi half in here and another pi half in here. And also, when we are working on that, we need to pay attention, is this value still in this interval? Yeah. So that is in the interval of 0 to pi. So it's a solution. So that's this one, and so that's this. And let's keep adding that. So n equals to 3, that x is equal to pi a plus 3 pi half, that is 13 pi 8. Okay, and again, 13 pi 8 is still less than 2 pi, so it's a solution. And n equals to 4, x equal to pi 8 plus 4 times pi divided by 2, or you can just use this one to add the pi half, and that will give us 17 pi 8. Okay, that's running an issue because this one is greater than 2 pi. So that is, we are going to reject this answer. So the only solution are all those. Okay, those are your solution. So therefore, I can write a solution as pi 8, 5 pi 8, 9 pi 8, and 3 pi 8. And you might notice that I did not check the value of when n is equal to negative, because I realized if I use pi 8 plus negative pi half, that's less than 0, so that's not in the interval. Right. Let's take a look at another one. How about this one? Cosine 2x, cosine x over 2 equals square root 3 over 2. Again, we need to consider this as a whole thing first. Okay, so in the interval, we are still looking at from 0 to 2 pi. And think about x over 2, that's a one big angle. So cosine what angle equal to square root 3 over 2? That this big angle, what I'm saying, is pi 6, right? Another one is 11 pi 6. Well, every 2 pi is repeating, so plus 2n pi. So from here, I can get x multiplied both sides by 2, so that's pi third plus 4n pi. And this one is x equal to 11 pi third plus 4n pi. And where the n is any integer. Right, so this is in general, but we say that we must have this value between this value, when I'm saying is the x. X must be between 0 and 2 pi. So we are going to check. So when n equals 0, again, I did not check negative 1 because we get negative value. So x is equal to pi third. Yes, that satisfies the condition. From this one, or x equal to 11 pi third. So that is still in this condition, 0 to 2 pi. That's the solution. And n equals 1, x equal to pi third plus 4 times 1 times pi. Well, that is definitely greater than 2 pi. No. How about x equal to pi 11 pi third plus 4 times 1 times pi? Also greater than 2 pi. No. Therefore, for this problem, the solution only have 2, which is pi third. And oh, hold on. I'm coming back to here again. This is not really true. I did not really pay attention for that. So because 11 pi third is equal to what? Is equal to 3 pi n plus 2 pi third, which is greater than 2 pi. Apologize for this. So you can see that this is rejected as well. This is rejected. So going back to here, then, which means, unfortunately, we only have one solution. That is, solution is only pi third. So it's always good to go back to double check. Let's take a look one more. We're going to find secant x minus pi 4 equals 2. Similar idea. Don't worry about this part, just consider this as a whole. And think about secant what angle is equal to 2 in the entire one period. And I can remember that's a pi third, right? So that will be this big whole angle is equal to pi third plus 2m pi, because every 2 pi is repeated. Or secant what else equal to 2? Secant is a reciprocal cosine, right? So that will be first quadrant and fourth quadrant. In fourth quadrant, that is 5 pi third. So x minus pi 4 is equal to 5 pi third plus repeated 2m pi. Okay, so when you have x is equal to pi 4 plus pi third plus 2m pi, that will give us 7 pi 12 plus 2m pi. And this one is x is equal to pi 4 plus 5 pi third plus 2m pi. And that one, finding the common denominator, if we simplify that, that will be 23 pi 12 plus 2m pi. So this problem asks you to find the general solution, which means I did not have the limitation for that, for like from 0 to whatever the value is, can be any real number. So therefore the solution is x such that x is equal to 7 pi 12 plus 2m pi, or x is equal to the 23 pi 12 plus 2m pi, and where the n is any integer. Right, so that's a general solution. And all those are linear, because cosine or sine or tangent, whatever the value you see, is just to the first power. Let's see more challenging one. We're going to solve the equation in the interval from the 0 to 2 pi. And from this one, and you can see that it is a second power. Okay, and if we can see, so for the, just like you solve the equation, think about this. This is cosine x squared minus 1 equals 0. And I'm going to highlight this one. And just think about whatever I highlight in here is just one big unknown. And so it will be like 2 times unknown squared minus 1. The way we solve for that is move the 1 to the other side, divide by 2, right? And take the square root. When you take the square root, means cosine x can be positive or negative square root of 1 over 2, which is positive negative 1 over square root 2, which is positive negative square root 2 over 2, whatever the way you see it. And so that we have two cases. Case 1, cosine x is equal to square root of 2 over 2. In this interval, x is equal to pi 4 And also 4 quadrants is 2 pi minus pi 4 is 7 pi 4. Case 2, you have cosine x is equal to negative square root 2 over 2. So you have x will be second quadrant, pi minus pi 4, that's 3 pi 4, or pi plus pi 4, that is 5 pi 4. So therefore your solution are pi 4, 7 pi 4, 3 pi 4, 5 pi 4. Alright, let's take a look at another one. So this one, well, if you don't see this, I can rewrite it as 2 sine x squared plus 5 sine x plus 3 equals 0. In order to have a problem a little bit easier to see, I would suggest you to think about maybe this is u, right? So that will become 2u squared plus 5u plus 3 equals 0. This is something we know how to solve that. You can do factoring, you can do quadratic formula. So if we factor that, that's 2u plus 3 and u plus 1 equals 0, which means you get 2u plus 3 equals 0, or u plus 1 equals 0, which means u is equal to negative 3 half, or u equals negative 1. Right? If it is a polynomial equation, we stop here, but remember we make it up the u indeed is sine x, so therefore it's just sine x is equal to negative 3 half. You unsubstitute that. Oh, wait a minute, remember that sine cannot be greater than 1 or less than negative 1, there's a range of sine. So for this part there's no solution. Okay. And this one will be what? Sine x is equal to negative 1, so that we get x is equal to 3 pi half. Since we only consider the solution between 0 and 2 pi, therefore that's the only solution. 3 pi half. Right, so from the green part, if you don't want to use the substitution, you can just start it from here and move on to writing the same thing. That will be just 2 sine x plus 3. Consider the sine x is one big unknown, okay, and times sine x plus 1 equals 0. So you get 2 sine x plus 3 equals 0, or sine x plus 1 equals 0. Then you will get into the same thing into here. Right, so it depends how you see the symbol, what you feel comfortable with. I think that will be the way you go with. Alright. Alright, let's take a look on number 8. And from this, after this problem, we take a little break and we come back to see using the identity to solve the trigonometric equation. Okay, take a look at this. Well, similar idea. You can replace u by cosine x and cotangent x by v, or you can just take a look here. Cosine x and cosine x, they are common factors, so we can factor it out. So that's cosine x times tangent square x minus 1 equals 0. Or minus 3. Caught my own mistake. So from here you have two factors. You can set cosine x equals 0, or tangent square x equals, let me not jumping that, minus 3 equals 0. So from here you can see cosine in the 0 to 2 pi period, x must be equals to pi half or 3 pi half. And from here, that will be tangent square x equal to 3, which means tangent x is equal to positive negative square root 3. And think about this is have two cases. Either tangent x equal to square root 3, or tangent x equals to negative square root 3. Tangent x equals square root 3x indeed is pi third and 4 pi third. And when it's negative, that's 2 pi third and 5 pi third. Okay. So overall, we combine all those, so the solution set have pi half, 3 pi half, pi third, 4 pi third, 2 pi third, 5 pi third. Alright. Okay, let's take a little break and then we come back to take a look at the rest of the problems in this section.